Bismillahirrahmanirrahim. Assalamu alaikum. Exercise 2.2. The unit is 2. Title of the unit is Matrices and Determinant. Question number 4 of exercise 2.2 is evaluate the following determinants. So you need to evaluate the determinants, and all the determinants which you need to evaluate in this question is the determinant of 3 by 3 matrices. Now part number 1 is 0 1 3 minus 1 2 1 2 1 and 1. You see that the square matrix of order 3 by 3 is given in the bars, so it is the notation for the determinant. So you need to find out this determinant, you need to evaluate this determinant. Before to evaluate this determinant, I briefly revise that how you can find out the determinant of 3 by 3 matrices. So this is the brief review that how you can find out the determinant of 3 by 3 matrices. If a matrix, let's say A of order 3 in journal form containing the element in first row is A11, A12, A13, and in the second row A21, A22, A23, in the third row A31, A32, A33. So this is a matrix of order 3. So there are 6 possible ways to find out the determinant of this matrix. You can find the determinant with respect to any row or with respect to any column. So here you see that there are 3 rows and 3 columns. So that's why there are 6 possible ways to find out the determinant of 3 by 3 matrices. Okay, if you want to interested to find the determinant of the given matrix with the help of any row, so for that the formula of the determinant of matrix is AI1, capital AI1 plus AI2, capital AI2 plus capital small AI3, capital AI3. Now, and A runs from 1 to 3. So here if you put I equal to 1, so this formula will become the determinant formula for matrix A using first row. If you put I equal to 2 in this equation, so you will get the formula for the determinant using second row, and if you put I equal to 3, so you will get a formula for the determinant of matrix A using third row. And similarly, if you are interested to use the columns to find out the determinant of the matrix, so for that the general formula will be A1j, capital A1j, A2j, capital A2j, plus A3j, capital A3j, and j runs from 1 to 3. So if you plug j equal to 1 here, you will get the formula for the determinant of A using first column, and if you put j equal to 2, so you will get the determinant formula using second column, and if you put j equal to 3, so that will be the determinant formula by using third column. So there are 3 possibilities and there are 3 possibilities. So there are 6 possible ways to find out the determinant of 3 by 3 matrices. Okay, so now the choice is yours. If you want to find expand the given matrix with respect to first row, second row, third row, or with respect to first column, second column, or third column, the choice is yours. But in these 6 possible ways, which one is the best choice? So remember, you see in these formulas the elements are multiplied with their cofactors. So if the element is 0, So you didn't need to find out the cofactor of the element which is 0, because cofactor is an element, 0 multiplied by that element you will get 0. So remember, the best possible option is choose such a row or such a column which contain maximum number of zeros. So in this case you see that the first row and the first column contain 1 0. So it is your choice, you need to expand it with the first row or first column. If you expand it with the first row, so you didn't need to find out capital A11 because small a11 is 0. So this selection of row and column in which the number of zeros are maximum is actually reduce your labor, reduce your calculation. Otherwise, if you expand it with the third row or third column or second row, so you will get the same answer. But the best to reduce your labor, to reduce your calculation, you need to choose such row or column in which there are maximum number of zeros. So expanding the given determinant with respect to first row. So for that, the determinant of this, let's say this is the matrix is denoted by A, so determinant in this case, let's say this is A determinant, let's say. So the general formula will be, now put just I equal to 1 in this, so you will get the determinant formula using first row. I am using it here first row, so from here you will get the general formula by plugging I equal to 1 here. So that will be A11 capital A11, A12 capital A13, A12, A13 capital A13. So you see that you need to find out the cofactors of the elements of first row. So actually A's A11 is 0, so this implies that the determinant will be equal to 0 multiplied by the cofactor of A11. So remember, cofactor of every element is a number, so that number multiplied by 0 you will get 0. So here you didn't need to find out the cofactor A11. So that will be 0 multiplied by this cofactor, you will get 0. So that will A21 capital A21, A13 capital A13. So this implies that, now plug this A12 by 1, and remember that capital A12 is equal to minus times M12, and this is plus 3, and this A13 is equal to M13. This is a minor. We explained this point. If the addition of the subscript is odd, so that cofactor will be equal to minus times the minor, and if the addition of the subscript are even, so that cofactor is equal to the minor, same minor, there is no difference of the sign. Okay, now so this implies that A determinant, this is minus 1. Now how you can find out the first, which is M12? So you need to cancel out the first row and second column. So this is your second column, cancel this. So and take the determinant of the rest of the matrix. You didn't need to do this labeling, or you can say under circling in a fair work. This is just for your understanding. Okay, now if you need to find out M13, so you need to cancel out the first row and third column and take the determinant of the rest. So that will be 1 minus 1 2 2 1. Now you see that these are the determinant of 2 by 2 matrices. So multiply diagonal with diagonals and non-diagonals with non-diagonals, and just plug a minus in between. So this is minus 1 minus 2, this is 3 minus 1 minus 4. So A determinant is equal to minus 1, this is minus 3, this is 3 into minus 5. So this implies that A determinant is equal to 3 minus 15. So this is equal to minus 12. So the determinant, thus the determinant of the given matrix, which is 0 1 3 minus 1 2 1 2 1 1, is equal to minus 12. You see, whenever you give a function, a matrix in the determinant, you get a unique number if the determinant is possible. Mean the determinant are only possible by square matrices. So this is part number 1 of question number 4. Now part number 2. Part number 2 of question number 4. So this is so simple. I am expanding it with respect to third row. So expanding with respect to third row. Why I am expanding it with respect to third row? You know a reason, that there is a 1 0. You can also expand with the third column, or you can also expand with the first row or second row, second column or first column. But here you will get a less calculation, because you didn't need to find out the cofactor of this element 0. Expanding with respect to third row. So that is, the formula will be this determinant 4 minus 2, this is 2 4 minus 6 minus 4 2 0. So now here will be minus 4, and into cofactor of, you need to cancel out the third row and first column. Third row and first column. Here the formula will be a determinant, this will be a 3 1 capital A 3 1, a 3 2 capital A 3 2, and a 3 3 capital A 3 3. So here you need to, if you want to find out the A 3 1, so the subscripts are E1, the addition of the subscript are E1. So this is equal to M31. So you need to find out M31, you need to cancel out the third row and first column and take the determinant of the rest of the matrix. Now here will be, this is minus, this is what is A32? A32 is 2, and this capital A32 is equal to minus times M32, so that's why this plus will be changed to minus. And how you can find out M32? This capital A32 is equal to minus times M32. So M32 means to cancel out the third row and second column and take the determinant of the rest of the matrix. Now plus, this will be minus 2, and this will be equal to M33, this capital A33. So cancel out the third row and third column and take the determinant of the rest. So you will get this. Now this is minus 4 minus 24 plus 8 minus 2, this is equal to minus 18 plus 4, this is minus 2, this is 12 minus 8. So from here minus 4, this is equal to minus 16, minus 2, this will be equal to minus 14, this is minus 2, and this is equal to 4. So when you simplify this, so you will get the determinant equal to 92. So the determinant of this matrix is equal to 92. So this is the part number 2 of question number 4. Part 3 and part 4 are similar. If you see to the questions, this is the part number 3. This is 3 1 2 6 minus 5 4 minus 9 8 minus 7. So you see that there is no 0 in any row or in any column. So whenever there is no 0 in any row or any column, so then the choice is you need to expand it with the any row or any column. So I am expanding this with respect to first row, expanding this with respect to first row. So that will be according to the formula, A determinant in this case will be equal to A11 capital A11, A12 capital A12, A13 capital A13, expanding with respect to first row. So this A11 is equal to 3 and capital A11 is equal to M11, mean this cofactor is equal to minor as it is. So cancel out the first row and first column, so you will get the determinant of the rest of the matrix is A's. This will be plus 1, but A12 is equal to minus times M12. So here this will be minus 1, and cancel out the first row and second column and take the determinant of the rest of the matrix. And similarly, this A13 will be written as it is, and this capital A13 is actually equal to M13. So cancel out the first row and third column and take the determinant of the rest of the matrix. So you will get this. After simplification, you will get the answer equal to 21. So this is part number. You can find the determinant of these by just multiplying the diagonals and non-diagonals and put minus in between. Okay, part number 4. Part number 4 is two 1 minus 3 1 1 0 minus 2 3 4. So I am expanding this matrix, this determinant with respect to second row, because you see that there is a 0 in second row and 0 in the third column. So you can also do it with the third column, so there will be less calculations. So for that, the formula is, in general, the formula for that will be, when you are using the second row, so the determinant of the matrix will be equal to A21 capital A21, A22 capital A22 and A23 capital A23. So you see that you are using the elements on the second row. So this A21 is equal to 1, so I will write 1. This A21 capital A21, this capital A21 is equal to minus times M21. So this will be minus. And how you can find out M21? You need to cancel out the second row and first column and take the determinant of the rest. So the determinant of the rest will be 1 minus 3 in first row and 3 and 4 in the second row. Okay, now then plus A22. So this will be plus 1 and capital A22 is equal to M22. This capital A22 is equal to M22. Now cancel out the second row and second column and take the determinant of the rest. This second row and second column will be cancelled. So these are the remaining elements. 2 minus 3 minus 2 4. Then A23 is minus 3, but this capital A23 is equal to minus times M23. So that minus and this minus will become plus, and this will be 3, and cancel out the second row and third column. Second row and third column and take the determinant of the rest. So this is 2 1 minus 2 3. So when you do the simplification, so you will get minus 11. You can do the simplification. So this is question number 4 of exercise 2.2. Thank you.